to introduce two more people. Tam, Twente-Am. Twente is a place in the north of the Netherlands, very close. And when I read their CVs, and I'm not sure if they're now in Twente or not, we had a very short talk to them on Monday, and one of you were in Germany, and the other one was, no, I think you were both in Germany, weren't you? So one in Berlin and one in the south of Germany, but you're still somehow located to Twente. You have to explain that within a minute. It's Tim Brodesser, head of research and development. He's an automation enthusiast. That's what it says here as a background, and he's based in Allgäu, South Germany. And then Adam Rumjahn, mechanical engineer from Canada, director of operation. He lives in Berlin. So this is not only Twente-Am, it's actually super international. Floor is yours.
Thank you very much. So I'll just share my screen here and we'll get it going with our presentation.
Adam, where are you? And Tim, where are you?
Yeah, so I'll get to that. So yeah, my name's Adam Rumjahn. I'm director of operations at Twente Additive Manufacturing, and as you mentioned, I'll be joined by my colleague here, Tim Brodesser, who's heading R&D. So we want to present to you today construction 3D printing and show you a little bit about the process of 3D printing our very first house. So just a quick overview about Twente Additive Manufacturing, or TAM. We are a Dutch-based company. This was kind of a strategic location for us, just being in the Netherlands and being surrounded by so much additive manufacturing in the construction industry. It was just a really great place to be. But we are also accompanied by a very multinational team. So I'm Canadian myself, and we have our R&D labs in Germany, where Tim and I are based out of, and we also have an R&D lab in Canada, where we have the majority of our printers and some of the larger printers, and an ongoing project going on. So I'll just to the next slide. So you can see one of our first prototype printers over here. This one on the left is in Germany, in Tim's lab. And the one in the middle here is our 3-axis Gantry printer. And the one that you see here on the right is our largest printer to date, which is a 9-axis printer. It actually features a 6-axis robot attached to a novel 3-axis system with a rotating axis. We actually used the printer in the middle to print the formwork. You can see it printing the formwork here. And that was for the first house build that we had. And the printer on the right was actually printing a lot of the components for our first house build. So we'll get into more of the details later. So what we set out to do was to design and print a house as a proof of concept, not only for ourselves, but also for the industry, because 3D printing a house is becoming quite a big topic in recent years. And there's been a lot of buzz around it, but we wanted to see what were the resources that it would take and what was the timeline that was actually needed in order to 3D print a house, along with all of the other considerations. But we wanted to take this opportunity to really showcase some of the benefits of 3D printing, the design freedom that you can have, and create something that wouldn't be typically possible or that easy using traditional methods. So we started with an inspiration of ours, which was the Fibonacci Spiral, in creating our house design. So you'll see here a rendering of our house design. So we were setting out a goal to print a small house, about 28 square meters. And the idea was to try to do this with a limited amount of resources and a tight budget, and see what kind of timeline this would fall under. So when we're getting to the idea of 3D printing a house, there's a lot of things that need to be taken into consideration. So we need to think about the print material and the properties of these materials, the different systems that are available for printing. Luckily, we have a lot of printers at TAM. We need to consider the building physics, the structural systems. So we're going to dive into some of these details in this presentation today. So the first thing that we need to consider is the print material. And as Wilson so elegantly mentioned earlier, there's a bit of a misnomer when it comes to 3D concrete printing, because we have traditionally been printing with mostly mortars, although we're starting to see now more people starting to print with concrete. And I think we'll start to see mortars being replaced with concrete in the future. But it is something that needs to be taken into consideration, because mortars have a lower compressive strength than concrete. And this plays into our structural strategy that I'll talk about in our next slide. But when it comes to these materials, it's basically one component materials, or 1K, and two component materials, or 2K. And one component material materials are materials that are already mixed together with an admixture. And due to this, they're usually having slower build rates. So these are very suitable for building large parts or parts where you need really thick wall perimeters. Whereas the 2K material is usually a material that is accelerated at the nozzle with liquid admixture. So this is kind of a set on demand material. And with this material, we're able to print really thin walls and really complex shapes with extreme overhangs. So we actually use both of these materials in our house build. And you can see on the bottom right here, we actually use the 2K materials to print these really tall, slender, complex columns for our Fibonacci patterns. So this brings us to building physics and our structural system. So since we are printing with mortars, it's something that we need to consider when we're designing these walls. So the strategy that we took in designing and building this house was that we didn't use the material itself as load bearing, but what we did is we used it as left in place formwork. And when we're designing these 3D printed walls, we really had to take into consideration how we would optimize the design for thermal insulation or thermal performance for that matter. So what we did is, you can see here in the bird's eye view in the middle picture, is that we printed these walls with cavities in between. So if you're familiar with 3D concrete printing, you may have seen this in other projects before as well. So we connect the outside perimeter and the inside perimeters with small pieces of rebar, and we'll fill those cavities with polyurethane insulation to get the thermal performance that we need. In terms of structural requirements, we worked with structural engineers, and what we did is we actually integrated formwork for structural columns, which are later filled with reinforced steel and standard concrete in order to get the structural requirements that we need.
All right, so getting back to the structural system, we also have a load-bearing wall here. So this wall that's on the inside of the spiral was actually filled with concrete as a shear wall to be able to take on some of the side loading that was needed. So this is how we were able to come up with a 3D printed design that would meet all of the specifications as required by regional building codes. So we do utilize 3-axis printers as well as 6-axis printers, or our 9-axis printer rather, in our project. And this really showcases how we use the 6-axis robot to print something that was really optimized for our case. So on the left here, you'll see an image that we were printing, and the layers on the left are actually smaller than the layers on the right. So we're actually printing this part at an angle. And the reason why we did this is because we had a sloped roof, and we would normally print with steps. But in order to fit that roof on there nicely, we printed this with a smooth angular surface, and that way we didn't require as much post-processing. And when you combine a 6-axis robot with 2K materials, you can get some really interesting geometry. So this video on the left here shows how we can utilize 6-axis robotics with 2K materials to get some really nice extreme overhangs. So just to kind of give engineers and architects out there a bit of an idea of what can be achieved. So when it comes to offsite printing, there are distinctive advantages and disadvantages when it comes to offsite printing, and these were some of the challenges that we had to face, and we want to present this to you so that the audience can also take this into consideration in projects that they might also embark on in the future. So with offsite printing, we have a controlled environment, and this is really nice because some of these materials are quite sensitive to temperature and humidity changes. So we do have this advantage of being able to have a nicer curing environment, as well as having protection already for our equipment. And the other part of it is that our equipment is permanently installed with a shelter, so we can print all year round, and we don't need to move the equipment onto the build site and reassemble it and take it away again. So that's one of the advantages of it. The con of printing offsite is that you do need to transport all of your items on site. So you couldn't really print an entire house in one shot and then move it on site because it would be too heavy to move. So what we had to do, as you can see here on the left, is we had to break up the house into smaller components that could be transported and then move them all on site and assemble them. And they're were definitely challenges that we had to take into consideration there, and we'll get into the details of that a little bit later on. So when it comes to geometry creation, we did have to take into account the thermal performance of concrete and how we would be able to reduce the thermal bridging of concrete. So we experimented with a couple of different designs for the load-bearing walls and non-load-bearing walls. So you can see here on the left some of the test prints that we did. In the middle are some of the formwork pieces. These are actual iterations that we did on designs for the structural columns, and how we were able to create perimeters that didn't touch from the outside perimeter to the inside perimeter to reduce thermal bridging. And on the right, you can see how we actually divided the house design into smaller components. So you can see we actually divided it into 20 different components. And this was part of the challenge when it came to logistics, which I'll talk about later on. But we had to make sure that these parts were transportable with the logistical systems that we had. So Tim was actually able to create an algorithm to be able to calculate what is the largest part that we could create that could still be lifted by our crane truck. So this is just showing a little bit more about our geometry creation. That's the finished wall on the left. In the middle, you can see some of these zigzag walls here. And on the bottom right, you can see how we printed many of these wall components joined together, which were later cut and segmented while they were still in the green state. So the mortar was still fresh and it was easier to cut. But this allowed us to print several components that could be self-standing, self-supporting, as well as take advantage of the material properties, because we did have to consider the cure time of the material. So when it comes to logistics, this was something that we had to take into account. How do we lift these parts? So some of the rebar that was placed in connecting the inside and outside perimeters were actually used as hoisting points. We definitely learned a lot from this experiment, but we also, found ways that we can improve this in the future. So this is kind of showing the process of lifting and all the considerations that we have to make. So luckily, our build site was only located 50 meters away from where we were actually printing. So the journey wasn't that long, but it is something that needs to be taken into consideration. And you can see a little bit of the assembly process. So there's a lot that needs to be considered in terms of how you move these parts, how you assemble them, and how you align these parts as well, because it becomes quite a jigsaw puzzle to build all these parts on site. So some of the challenges, we did have collapsed parts, but this is really because we weren't respecting the material properties, and we were pushing our printers to print as fast as possible just to see what we could accomplish. So we do have to expect that you might not always have a perfect print. One of the, I guess, advantages of us doing this as an off-site printing prefabricated method is that we were printing these components, and then when we have a part failure, we can just simply reprint that part. So this is something that might be a little bit different if we were printing on site, and could be a different challenge altogether if we're printing a whole house in one shot and we have a print failure. The other part of it is cutting cured parts. It's something that we definitely want to work on in the future, but this process still requires some post-processing and cutting of finished parts. And we hope that we can improve that in the future to minimize that. And the other part of it are just inconsistencies. So, this is something that we experienced. Sometimes it's related to the material, sometimes it's related to the hardware. And we think that with further improvements to the hardware on our end, we can possibly improve some of these inconsistencies that we're seeing in the prints. So that's it, just a quick summary. It took us about 11 days to print about 20 different parts. The next slide here will show you a little bit of the construction from start to finish, just to give you a few impressions of what things are looking like. So now I will pass it over to Tim, who's going to talk about scanning to print and scanning to fit, and how we're going to work some of these strategies into our workflow to really kind of push the envelope with additive manufacturing in the construction industry. So, Tim?
Okay. Okay, I'm starting again. So I have the pleasure to present you those two projects, which are called Scan to Print and Scan to Fit. They were partly inspired by work of Bastian Wieberneck and Oliver Tessmann on their digital rubble project. So we've been using different 3D scanning options like photogrammetry scanning using drones or handheld devices, as well as laser scanners. And this we did for a couple of projects. Here you see some experimental prints that we've been doing on a build site in British Columbia, Canada, where our R&D facility is also located. Fun fact about this project is we got the scan in Canada. We sent over the mesh to Germany, where the geometry was created as well as the toolpath. And the next day, the table pedestal got printed in Canada again. So that's how you see how we're working all over the globe, actually. Yeah, from those fun projects, we're actually trying to build a house on a very challenging build site here. You can see in the upper area, close to the water line, it's on Kootenay Lake in British Columbia, a very nice area, where we're trying to build. And you see that we started digging around there already, and we found bedrock right under the surface. So here you can see how it looks like closer, as well as the scan we made. And there are areas that are shaped like a horseshoe that are made of bedrock. So in normal build scenarios, it would demand blasting or somehow flattening of the area to build a house there, which is something we didn't want to do. We wanted to use the virtues of 3D printing in order to build the footings and formwork for a house, of which you can see a preliminary design on the right, which shall be 3D printed later on as well. So in the top pictures, you see me actually placing an item that was used as a test for a formwork piece of the actual scanned area. And I chose exactly this point because it was, we wanted to verify how exact the scan was and how well our print would actually fit. And this one even had an undercut. So you can see how the printed element actually nicely wraps around the rock there. So yeah, we could probably call this a success. And yeah, so this is where we are right now. We have the conclusion how we can actually build the foundation for this house build that hopefully happens next year. And yeah, in our last slide, I just briefly show you one of our other projects, which we call Scan to Fit, in which we actually 3D scan our printed elements for a couple of different reasons. First, there is still a very open subject of quality control of printed elements. So now we can verify at least the geometry of the printed part and compare it to the digital model. As well as another thing that we are working on together with Incoming Eye, which is focusing on augmented reality for the assembly of the parts. This was sparked by our experience assembling the Fibonacci house. So no straight line makes it really hard to place those items actually on site. And yeah, so I've been quick as I could here, Uli, and like to pass over one more time to Adam to, yeah. Adam?
Adam, you're muted.
Muse. There we go. Great. So that pretty much concludes our presentation. I apologize, we had to keep it a little bit short, but if anyone wants to contact us with some further questions, feel free to contact us. I just want to end off by sharing a slide of our team. So none of this would have been possible without the help of our amazing team, which is spread kind of all across the world, but most of us are in Canada. Tim and I are here in Germany, and we still have people representing us in our Dutch office. So thank you, and congratulations to this team. It's been an immaculate year, even with everything considered with this pandemic. So I'll just finish the presentation there, and maybe leave you with a couple of pictures in the slideshow. Thank you.
Digital applause. That's nice. I slowly start getting into the discussion, and Roland, please join me to do so. I have to ask this question: why the north of Netherlands? Why Twente? Twente is nice, but you have to have an argument.
Yeah, well, I mean, it kind of just came by convenience. We had most of us had previously worked together in another company in the wind energy industry, and there was a satellite office set up in Enschede, and you know, when that project was basically sold off in an acquisition, it kind of became the stomping grounds for us to kind of experiment with other ideas. So. Okay. In the founding team, you know, we got together and we decided that it would be a really nice strategic place to start a new business, especially just based on all the support that we're able to get from the other universities, research institutes, as well as engineering and architect companies like the Devine and Bos. So it became a really great place to start this business and be surrounded by a whole bunch of local talent also working on large-scale additive manufacturing.
Interesting, really interesting decision. I get the story.
Thank you.
Yeah, nice. Roland, do you have a comment?
Yeah, look, I really enjoyed both those presentations. I guess one thing for Adam and Tim, I found it fascinating watching you explain how you deal with the different, I guess, relationships between design and limitations of technology. And I guess this is something that's kind of really, as an architect, is really close to my heart. It's like, what can or can't we design with these particular fabrication technologies? And I guess it was also interesting hearing how you're tackling a whole series of problems in concrete that we're tackling in 3D printing polymer. So we're also, you know, dealing with these strategies of permanent or stay in place formwork and how you cast into them, or non-horizontal printing layers, even issues of start-stop and how do you insert other elements into it, or how do you prefabricate things as opposed to print on site, and what issues that causes. I guess the question I have for you perhaps is how does it change design? And the example I love to cite in this is the first iron bridge that was built in the 1770s in England, and the iron bridge looks like a timber bridge, and it's because all the kind of design understanding in terms of detailing, in terms of structure, was based around timber construction. And so when they've shifted into new material, they basically built a timber bridge, but from metal. So what I'm really interested in with 3D printing is, do we end up doing that? Do we develop this a completely new way of building, but do we keep building the same things, which don't actually really make sense to build with that technology? So in other words, I guess I'm rambling, but the question I'm trying to get to is like, what have you sort of learned from the biases of your technique in doing this, these projects, which is then changing the way you're kind of conceiving of, how a house would be designed, or how a building is designed, and how its tectonics and its structures, etc., are going to be different because they're printed as opposed to being produced in some other way.
Yeah. Thanks for that question. So it's a challenge that we have to face today with this new technology, because we're used to building, especially when it comes to concrete, in a very different way. where we're using formwork and we're pouring, or we're doing assembly with precast items. But you know, I believe that additive manufacturing will truly change the way that we will build in the future. It's just that there's a bit of this knowledge gap, so people are still not really fully understanding how to utilize additive manufacturing to its full potential, and what some of the limitations of additive manufacturing are as well. So you know, you can see that we're used to building very square or rectangular shaped, orthogonal shaped buildings, and we might have multi-level buildings. But at this point in time, you know, we couldn't build a whole house in one shot that's 2 levels or more. So we need to find some way to support the floor and the ceiling. And you can see in this first house build, you know, we didn't venture into printing a roof, but this is something that I definitely see happening in the future. So when you see, for example, the project in the Netherlands, the Milestone Project, these are buildings that have the entire structure printed all the way up to the roof. And I see this as one of the greater examples of how we can utilize additive manufacturing in a way where we're changing the way that we think about the design of a house based on the technology, and not trying to use the technology, new technology, to build things in the traditional ways that we're used to. So I think there's going to be a paradigm shift happening in the future, but in the meantime, there's still this knowledge gap that we have to address, in which traditional fabricators and the construction industry, for that matter, is still used to doing things in a particular way.
Wise answer. I fully agree, and it takes some time to get to that change of say understanding, implementing this technology.